Okay, here are some basics about ARP, the Address Resolution Protocol. ARP is a really important protocol because it plays a really important role in the functioning of local area networks and how local area networks function. ARP resolves IP addresses to MAC addresses at layer 2. So if we want to send a packet or send a frame to another host on the local network, or even let's say our router or gateway, we have to know the MAC address of the host that we want to deliver to. And what ARP will do for us is it will help us resolve that MAC address. What is that MAC address from an IP address? So ARP resolves IP addresses to MAC addresses at layer 2. We need ARP for the functioning of Ethernet, essentially. And ARP's a pretty interesting protocol because it's used in some security attacks and what's known as ARP spoofing. So it's a pretty interesting protocol on a lot of different layers. I'm going to demonstrate a little bit about how ARP functions, so let's get to it. Let's say, first of all, I have a diagram here, and I've got two networks here. We're going to look at this network over here. So here's a laptop, there's a wireless router, there's the internet. All right. Now, if I want to get a web page from the internet, I'm using my web browser and I want to, let's say, go to Yahoo, right? I'm going to need to send that request to my gateway, and it's going to go to my wireless router. But to deliver that request to my wireless router, I need to know my wireless router's MAC address, because on a local network, frames are delivered to MAC addresses. They're not delivered to IP addresses, they're delivered to MAC addresses. IP addresses help us to reach networks, to find networks or route data to different networks, right? But to deliver the actual frames on a local network, it needs to be delivered to a MAC address. So I need to know my MAC address, the MAC address of this router if I want to send a packet to it. So if we look at, let's say, my command prompt here, I've got a Windows 7 machine, I've got a command prompt, right? And we look at the ARP cache by typing in ARP-A. You can see that at the top here, my main interface here is 2.103. That's me. And you can see here that I know about 192.168.2.1, right? And that is my router, my wireless router. And you can see I have the MAC address in my ARP cache. So ARP has already helped me resolve the physical address of my router. And you can see here that I don't know any other hosts on this network. I cannot deliver to any other hosts on the network, basically, because I don't have their MAC addresses. I need their physical addresses if I want to deliver a packet. So right now I can send to my router. Now some of these other addresses are different. 2.255 is a broadcast address, and you can see that it has an FFFFF. These Fs are a broadcast MAC address, layer 2 address. And then these 224 addresses and this 239 address are all multicast IP addresses, and they all have multicast MAC addresses. Notice how all the MAC addresses start with 01-00-5E. If it starts with that number range, it's a multicast MAC address. And then down here you can see 255, 255, 255, 255, and then another broadcast MAC address. If you're interested in MAC addresses and you want to know about these multicast MAC addresses, you can look it up on Wikipedia and find these number ranges for certain IP addresses and certain MAC addresses like multicast addresses. Okay, so I know my router's IP address and I know the MAC address, so I can deliver to him. Now, the way ARP works is it resolves this very issue. So what we're going to do is we'll just run a test. What I'm going to do is say ARP-D, and that will delete my ARP cache, right? And now if I run an ARP-A command, you can see that, well, I'm not supposed to have that. So we'll try that again. ARP-D and then ARP-A and ARP-D. Somebody's broadcasting, and ARP-A. Okay, no ARP entries found. All right, ARP-D, ARP-A, no ARP entries found. Okay, so there we go. So we've deleted the ARP cache, And now what I'm going to do is I'll open up Wireshark, right? And I'll go to Capture, Interfaces, and my active interface is right here. You can see packets. So I'll go to Options and I'll set up a filter. Now I've already set up a filter with this. If I say Capture Filter, I selected New and I created an ARP only filter, so it will capture only ARP packets. You can see it right there. ARP only, and then the filter string is ARP. Click OK and click Start, right? And now what I'll do is I'll open up a browser window, let's say, right? And I'll ask for, let's say, yahoo.com, and browse to yahoo.com, and I should be getting some action in my ARP window, and I am not. So let's try to do that again. We'll make sure we delete the ARP entries. Okay, nope, I've already got it there. Delete, delete, no entries found, and I'll go to my window and hit refresh, and I'll look in my capture dialog in Wireshark, and you can see here I've begun to capture some ARP packets here. So now that that's done, I'll say capture stop, and we can take a look at these ARP packets that we captured with Wireshark. And basically what I was doing was deleting my ARP cache, right? And so that I don't have my router's physical address resolved, so ARP will function and then we can capture those packets. So you can see here that ARP's done just that. Okay, so let's analyze these packets that we've captured using Wireshark. Well, first of all, you can see that there's no IP addresses involved here. We're talking about layer 2 here. So the source address here says Cisco, right? And you can see here this is a MAC address, but instead of just all hexadecimal numbers, the beginning says Cisco-LI. Well, why is that? Well, the first 6 characters of a MAC address is the Organizational Unique Identifier, or OUI, which identifies the company. So we know right off the bat that my wireless access point has a Cisco NIC, basically, or Cisco MAC address. And that would make sense because it's a Linksys access point and Cisco owns Linksys, so, and it says Cisco LI, right? And you can find that, you can just look that up online and find those MAC addresses, but that's the way Wireshark can identify it as a Cisco device. And the destination MAC address is an Intel MAC address, and this is my MAC address. So this is a message from Cisco to me saying who has 2.103, tell 2.1. So who has my MAC address, tell the router. So the router is trying to find my MAC address, right? The router is trying to fill its ARP cache with my MAC address. And you can see on the next line, on line 2, I have replied and I've given my MAC address to the router. And then on line 3, you can see that I have, this is Intel, so this is my NIC, this is my MAC address, and I've sent a broadcast MAC address, meaning all Fs, right? FFFFF, and you can see down here that there's the Fs right there, right? So broadcast MAC address, ARP protocol, who has 2.1, tell me, who has the router's MAC address? And then the router replies with his MAC address, right? So here are some ARP exchanges, and this is my computer finding out the MAC address of the Linksys router. So the point is that before my computer can request that web page from the internet, basically, or from the router, request and go to Yahoo and get that web page, my computer needs to find out the MAC address of my Linksys router so I can send the frame to the Linksys wireless router. So I have to resolve the MAC address first before I'm going to be able to get that Yahoo web page. So if we go back to the diagram, so if I want to get Yahoo out here on the internet, I need to resolve the MAC address of my wireless router right away. And you can see now, if we do an ARP A -A, I have resolved 2.1, and I know the MAC address of the wireless router. And this process happens behind the scenes without you even knowing it, but we can observe it if we capture the packets and take a look at it.